the IP and the lag incremental update. So this part are the features that are very fundamental, but are missing in SONiC for a period of time. So basically, we're using static configurations get from the mini graph, and then we use that piece of information to generate some static configuration files, like the etc network interfaces file and some TMD files, so that we can control the IPs of all the interfaces, and we can control all the port channels in our SONiC system. So, can you still see my screen or not?
We can see your screen.
Okay, that's good. Okay. Now I'm going to continue. So basically, what I'm going to do in this design doc is that I want to enable the functionality of like flexibility of configuring like all the IPs of the host interfaces in the system, and I also want to enable the flexibility of like creating the lags, removing the lags, and like manipulating the port channel members. So that's going to be covered in this design doc. Yeah. So let me know if you have any questions. Just I would just pause and answer it. So I'll go ahead and describe a little bit about the requirement. So I'm going to divide my work into like several phases. The first phase is phase 0. This means that I'm like after my change, or like during each pull request or the progress of my change, I will not going to break the current behavior of the SONiC, meaning that I want to keep the current like booting procedure to be as smooth as possible, so that after booting up the device, we should still have a working like totally working switch that's not going to behave like anything different from what you've been experienced before, meaning that all the IPs are assigned correctly to all the routing interfaces, all the port channels are created, and all the members are enslaved into the port channels. And all the ports are set to admin status up, and all the MTUs are set correctly. Right now, our like default MTU is 9100. This 9100 value will be propagated to all the ports. So what I'm currently working on is the phase 1. Phase 1 meaning that I'm going to remove the remove a lot of content in the etc network interfaces file. We know this file contains previously it contained all the front panel interfaces configurations and all the port channel configurations. So all the IPs are there, all the MTUs are there, and once the port is created, it will be brought up as admin main status up via this file. So I'm going to remove this file. The benefit of this is that all the configurations will then be stored in the configuration database, so that this database can be saved and can be inherited during multiple reload. That's better than a static file, which cannot be easily added. The other part is the TMD configurations. So right now, all the TMD configurations are stored in the TMD Docker in the folder etc TMD. So all these configurations were generated via the mini graph. So the mini graph provides all the information and then translated into like several static files, put it into the folder. So these are also static right now, and it's not that easy for user to create new port channel interfaces or like manipulate current port channels. So what I'm going to do is to remove these static configurations from this folder so that all the port channels will be created like dynamically according to the content in the configuration database. One important part in my work is to enable the command line tools so that we can use the command line also to do this incremental update. So, for example, like we want to bring down all ports, all port channels, instead of doing IP link set or IP link set up, IP link set down. We can use command line config interface up down so that we can preserve the current admin status of all the ports and port channels. Similarly, it's like for the IPs, instead of like doing the IP address add and IP address delete, creating like funds so that we can assign and remove all the IPs towards all the front panel ports and all the non-LAC member like port channels. I'm also going to support the change of the MTUs, and for the port channels and the port channel members, it's also supported to create new port channels, remove old port channels, and add or remove members of port channels. And in this phase, I'm also going to like make sure that restart Docker SWSS will not break, because right now restarting the Docker SWS will not going to trigger, for example, TeamD restart or the Docker BGP restart. And after restarting SWSS, the system still works fine. So I want to keep this feature as a backward compatibility so that system won't behave like the command of like system control restart Docker restart service SWSS will still work as before. So there's some notes to my work items. The first one I think is that conflicting configurations that cannot be resolved easily. So I'm not going to support them, because right now this part is maybe included in the future like configuration validation part of the work, so that I'm not going to cover the configuration most of the configuration validations in my work. For example, like I don't want to. It's hard to deal with scenarios like if a port has an IP and I want to move this port into a port channel, then the behavior will be not easy to be defined. It's better to remove the IP of the port, and then we can move this port into a port channel. Similarly, it's like I'm not going to support scenarios like to assign an IP to a port channel member. Also, it's like, for example, I'm not going to support adding or removing non-existing ports into a port channel or removing from them. Yeah. So basically, I'm just going to support very fundamental and well-defined workflows described as above. Yeah.
Yeah. So then, can I ask you a quick question here?
Yeah, sure.
What do you mean by non-existing ports? If it's a port that doesn't exist, why would it be in a port channel? Is that because previous configuration error?
No, it's like, for example, typos, or for example, the port is or something like that, or the port was not there, or for example, I don't want to add a VLAN into a port channel as a member. I don't want to add another port channel into a port channel as a member, such kind of things.
Okay, so but if you don't want to add them in, if it's a mistake to have them in, why wouldn't you supporting remove them from the port channel if they were there by mistake already?
Then what's the behavior of adding them into this configuration? Then the configuration itself is not valid, right?
Yeah. So I think what I'm trying to say is maybe there's a scenario that before this protection was there, something get added into the port channel by mistake, and we didn't realize this error until we run into the new version with the protection. Then I think at least you should supporting remove them from the port channel. But I agree that you shouldn't allow adding them to the port channel.
So I think this can be done via like a basic validate in the SONiC utility, like the config command, so that we can only add front panel ports into the port channel. I think that can be done. Yeah.
Okay, so you will allow, if there's an error in the configuration, you allow them continue existing?
No, I won't.
No, I mean existing in the configuration file, but they won't get applied.
Like,
or maybe I'm missing something.
So you're saying that the current configuration is not valid?
Correct.
I think then if the current configuration is not valid, I think it's not that easy to remove that, because all the like upcoming like operations cannot be well defined for its behavior. So that's tricky. Yeah. And I don't think for the current system you can put like invalid configurations into the configuration database and make everything still work fine.
Okay, that's okay. Let's think about that offline. We don't have to make a decision here. Thank you.
Mm-hmm. So the other thing is that for port channel and port channel administrators are like they are set separately. For example, like if a port channel is set to administrators down, maybe all the port channel members can still be administrators up. So that's one note. And by default, all the ports and port channels are set to administrators up, and MTU is set to 9100. But this piece of information is stored in the configuration database, and people can just change it to anything they want. One more thing about the MTU is that a member port of a port channel will inherit the port channel's MTU, meaning that if a port was set to 1500 and it's put into a 9100 port channel, the MTU will be set to 9100. But when it's moving out of the port channel, it will be reset back to the 1500. So that's phase one of work. So after this phase, so all the command line tools can be used to execute all the incremental updates. So what will be covered in the future phase? So the first one is that I want to also move the loopback interface information, this piece of information, out of this file so that it can be managed by the port manager D. The other thing that I want to support the Docker teamd restart. Right now, Docker teamd restart cannot work due to various reasons, and in order to make it work, there are still some issues, including that some issues including IPv6 neighbor removal, or some implementation issue of removing a router interface. So that one because of such kind of issues, I will put into phase two, so that I might need to have some more time of deal with the leading issues before I really solve the Docker teamd restart scenario. So let's go on with different components requirements. So the orchestration agent, this part doesn't need a lot of change. The most significant change is about the MTU, so that we are able to change the router interface MTU according to either the port MTU or the lag MTU. And also, after changing the lag MTU, all the ports under the lag will be updated. So for there are a bunch of syncd sync daemons, like port syncd or team syncd. So hosting D previously was responsible for listening to the network messages of setting admin status and MTU. So this part will be removed so that only the port manager D we're going to set the admin status of the kernel and the MTU, as well as like writing to the application database to let orchestration agent pick up what's the current status of admin status and MTU. The other thing about the state, so the state okay means that all the netdev is created. So after the netdev is created, either port syncd or team syncd, we're going to write state okay into the state database. So this one is important because that some other like daemons will require the netdev to be existing in the system so that they can execute, for example, IP link commands or the teamd or teamd commands. So the manager daemon are newly introduced here. So 3 newly introduced manager daemons, including like the port manager D, interface manager D, and the team manager D. So each of them are responsible for a specific configuration database. The port manager D is going to like listen to the port table in the configuration database. Like the interface manager D will listen to 3 tables: the port interface, the port channel interface, and VLAN interface. And team manager D, we're going to listen to the port channel and port channel member tables. So all of them are orthogonal to each other, so that they are not overlapping of like listening to the same tables.
So what is the motivation for having different? This is Nikos, by the way. What is the motivation for having different managers rather than having one interface manager that deals with interface statuses, MTU changes, IP changes, because and also port channel memberships and so on, because everything pertains to an interface, and all operations on actual interfaces, whether they're virtual, whether they're physical.
Whether they're virtual, what do you mean by saying virtual?
So virtual interfaces, they're ephemeral interfaces, like port channels, right? They're not actual front panel ports.
I see. So interface manager D is like managing all the like interfaces, meaning that it is like responsible for all the IP related things. And I want to separate them.
Why?
They're listening to I only want to listening to the so you are saying that they are separated, for example, the port channel and VLAN interfaces, they are separated into 3 tables, right?
I'm saying that basically you will find it a lot easier in your design or your implementation if you have a single entity called interface manager. And the interface manager encompasses the functionality of port manager, interface manager, team manager D, because effectively that entity deals anything that has to do with the properties of an interface, whether that interface is physical, actual front panel port, or ephemeral, or virtual, or anything, setting, unsetting IP addresses, MTUs, admin statuses, anything, because that allows you to reduce code in certain cases and allows you to enclose the functionality in actual one entity.
Yeah.
But
go ahead if you.
No, that's my advice.
Okay. So the reason of doing this, so you can see from here that right now the port manager D and interface manager D, they are doing like small chunks of work. They seem to be combined, are able to be combined. For the team manager D, it's sitting in a different Docker, so it's sitting in the teamd Docker. So that's why it need to be separated, and it need to talk to to execute teamd commands, and this is more like coupled with like teamd, so that's why I put this out of the other things. Is that a valid reason? I think.
Yeah. So I understand the rationale here. Then I would suggest either get rid of TeamD Docker or encompass the functionality there. You will find it very difficult in the future to have interactions between TeamD and the interface manager entity, whether it is split or not, when you have to do actions and you have to communicate those actions back and forth and outside the Dockers, right? Because it's different entities, right? It's different processes, different everything.
Yeah, so I do encounter some difficulties while having a separate Docker of TeamD. However, I find some benefits of.
I think probably Nico's just asking that there is a one manager to sign all the interfaces. I think that is done by interface manager D, right? So it's already, you're already doing that.
I think Nico is saying that this manager D may also can be responsible for like for channel manipulation, such kind of things.
Correct. I mean, I think it should be responsible in interface manager, wherever you want it to reside, should have anything that has to do with an interface and its properties. It doesn't matter whether the interface is front panel port or ephemeral like a loopback or virtual like a VLAN or a port tunnel and so on. Put the functionality in one place that would allow you not only to remove code, but also allow you to make it more modular, whether you want to restart in the future. You don't have to coordinate across processes, across manager daemons and so on, or across Dockers. That's my advice, and don't want to sort of like waste more of the time in the meeting in that, but I would suggest you consider that.
Yeah, so
but I think just try to understand, the perspective from Nikos is trying to, reduce the redundancies in the system that, have one place to handle the common functionalities in terms of interface. But I think that is interface manager, once the interface is created, like the port channel or VLAN or physical interfaces, so once they're created, then I think we're leaving the interface manager to handle all the configuration of the interface, like IP configurations. So then I think that the current design is what the Nikos is asking, right? So like the port channel setup, I think that is special to port channel. So that's why we have the port channel manage D, which handles the port channel specific stuffs.
Right, but do you feel that that's needed instead of having a? I understand that you have a port manager D in terms of, but not as a separate entity, right? What I'm saying is that port manager D functionality is part. I mean, the port channel is just an interface. I think it will be. Yeah, go ahead.
Yes, I mean the port channel is. I didn't quite. The port channel. Once the port channel is created, then we leave to the interface manager to sign all those IP addresses. Yeah, so it's not saying that we have two daemons to sign interfaces to different ports, right? Different kinds of ports. Is that what you are referring to?
Yeah, that's fine. I mean, if we want to call it port manager D and it's just the same daemon that resides in the same Docker, but it just runs different code and we've split it for functionality's sake, I'm fine with that. I don't have a problem. All I'm saying is that if you encompass everything under an interface manager name, creation, deletion, attribute changes, layer 2, whether they're layer 2 attributes or layer 3 attributes and so on, because it will be making it easier for newer people to understand what is the functionality that is handled by this entity, rather than trying to figure out what does the port manager handle, what does the interface manager handle, what does TeamD handle, and so on. And I'm trying to understand the interaction and get it right. That's all. I don't want us to spend more time on my question.
Okay, I can get this. Yeah, we can.
So I think then probably shorthand would be helpful to to have a high level description of each manager D to say what they are responsible for. Then we can check whether we are classifying those functions properly across those manager Ds or not.
That's fine. That's fine. Right. But I would also consider team D being, I personally, right? I'm just saying, just go ahead and do it. But I would consider team D being eliminated. That's all.
This Docker, yes. Okay.
So what do you mean by getting the team D eliminated? So we're using the team D to do the port channels.
Do you think it offers a value that it is in a separate Docker, or do you think that it adds complexity over the interaction, since in some cases there has to be interaction across Dockers?
So that's I think the reason we separate the team, the lag as a Docker, the team as Docker, because we think the lag is extra functionalities. Maybe people can use something other than the team D to do the lag. So that's why we separated them out as a different Docker, so that in the future maybe architecturally we are better positioned to be able to replace the team D with something better, maybe MLAG, those kind of things. So so that's why I think we have those team D as a separate Docker.
Okay.
I mean, I didn't want to move them into the let's say SWSS Docker, because we think that it's not the core part, it's some extra just provide lag functionalities, and I think in the future maybe we can replace it with some other modules that support the lag if it has better or have more features than that.
Yeah, I think that's also some benefits of like isolating the team D as a separate Docker, so that once we restart the team D Docker, we can restart all the configurations solely related to like port channels. Yeah, so let's continue. So I was going to add some like command line support for this feature, so that we can add IP, remove IP, add port channel, remove port channel, and do some member manipulations. So we can also support the main link option and the fallback option for the port channels. One notice is that due to the limitation of the team D, we cannot change the main link configuration and fallback configurations. So these two options are going to be create only. And after it's created, the only way of like changing it is to remove the current port channel and create a new one with a different configuration. So let's go back to the go on with the database. So there's some database changes in the configuration database. So we know that the port configuration port table, we're going to have the admin status and MTU. For the interface table, it's already there. All the interfaces are there, and with name and IP. And the thing we add here is the port channel table. So in this table, the port channel are having like 4 like attributes. Other than the admin status and MTU, so it will have the main links and fallback option. The schema is listed here. Straightforward. And also we are going to add the port channel this is going to be a port channel member. I'm going to fix this. So there will be a port channel member table. So the port channel member table will contain all the port channel and associated with its members names. Yeah. Oh, it's here. Yes. Yeah, this one is the port channel interface table. So this one is describing the IPs of all the port channel assigned to all the port channels. So let's go on with the daemon design. So for all the daemons, due to the requirements, so orchestration agent will not be changed a lot. The port manager D will going to responsible for the port configuration table, and the interface manager D will going to monitor all the interface related tables, including the port channel, and VLAN. And the team manager D will going to monitor the port channel and port channel member configuration tables. So because of the modules are like isolated with each other, so all the manager daemons are orthogonal to each other, so that we know each table are like consumed by which table are consumed by which daemon.
So let's say that you have an interface that has an IP address, and you're trying to put that as a member of the lag of the port channel, right?
If I have a port with an IP, that's not supported. So
no. I understand. You mentioned it earlier. You don't plan on address that now. That's perfectly fine.
Right.
Thinking a little bit into the future, if you were to like to address it, and I don't want this to become a design session for that, but thinking into the future, I'm hinting that Team D, which actually handles the membership in the port channel, would have to wait for some other entity, since Team D doesn't handle the IP address addition removal, to do this or signal this to the other entity, since it exists in a different Docker, to say, hey, by the way, I want to add this, and automatically please go ahead and remove the IP address so that the operation can take place. That was the added complexity that I was trying to highlight earlier, that you have two different entities that somehow they need to coordinate and interact with each other, but they're on different Dockers/processes. That's all.
So this kind of complexity, I will suggest to resolve this before they are reaching the configuration database, meaning that this can be resolved by, for example, like configuration validator, saying that this kind of manipulations are not valid. People need to address them before, or that this kind of logic can be like hidden inside, for example, command line. For example,
I agree with you. Right? But what I'm trying to say here is that the Team D, who presumably was handling the front-end configuration for adding the member to the port channel, would now have to know and realize about IP addresses.
Yes,
or
that's true. So that it should have the pre-knowledge of saying that the IP is not there, so that it can directly go ahead and do this. It doesn't need to wait for anything because it's guaranteed for the team manager D.
Yes. I agree. I don't disagree here. All I'm saying is that there is the added complexity that now, even though Team D was only handling membership and creation, deletion, now it also needs to have intimate knowledge as to get the IP address, if there is one, and signal that, hey, I cannot add this here because it has an IP address. All of a sudden now it's leaking information from outside that it has to have knowledge about IP addresses, about other things in the system that are the sole responsibility of other components, but clearly not for manipulation, but for error checking, right?
Yes, so this piece of information, even if it's inside one daemon, this piece of information should still be there. So this piece of information will always be somewhere inside the whole system. So if we're going to go ahead having all the daemons separate, like sitting separately, this piece of information should should always be there, like, and we should deal with this kind of complexity. Yeah, I think that's what I'm thinking about. Yeah. So let's go on with the working flow. So right now, the only thing we need before for checking the, for example, for setting admin status and MTU configuration, is that we need to get the state from the state database, so that we can make sure that all the netdefs are created, and then for example, the port manager D is going to execute the IP link command to the kernel, as well as write to the application database, so that this information can be picked up by the orchestration agent and then calling the corresponding like side functions. Similarly, as the port channel and port channel member configuration flow. So for port channel, it's straightforward, because once the port channel configurations comes, we're going to directly call the teamd command to start a new thread of teamd, and teamd will go on and create the netdev, and then the teamsyncd will going to pick up this information and let our orchestration agent know, and then we will create the lag under the ASIC. For the members, the only difference is that before we're going to enslave the port channel member, we're going to check if the port is already created or if the port channel is already created. And then we can continue the straightforward flow till we are calling the side function of create a lag member or remove a lag member. For the IP configurations, it's similar. So it's like we're checking if the port or if a port channel netdev is created, and then we're executing the IP address command. Right now, the interface syncd is going to listen to the network messages, so that once a kernel has new addresses, we're going to pick it up. Once the address is removed, we're going to also know this and then update the application database, so that we can finally like call the side router interface function.
So here for the IP configuration flow, do you have plans to do basic checks, or you will just push whatever it gets pushed into the kernel? And I'm thinking more along the lines of overlapping IP addresses, which there is some check in current org agent and there, as well as link local addresses and so on. Are you planning on putting
validation part? No, I'm not going to put. So I'm just going to take whatever in the configuration database and then execute the IP address command.
Okay.
Yes.
Okay.
So yeah, thanks. So this is a device starting workflow. So the first part is to create all the ports.
I just want to add into Nico's. I think the validation, like overlapping IP addresses on the interface, that should be prevented before they even get into the config DB. So
but you're saying that
those kind of, yeah. So those kind of configuration validations, like user, if they get into the wrong IP address, overlapping addresses on the same interfaces, those kind of, or on different interfaces, I think those kind of configuration validation should be prevented from getting them into the config DB, because once we get into the config DB.
So you're saying that basically the front end, whatever front end we provide for configuring IP addresses in SONiC, that should be responsible for doing the validation and should not enter something that may not be valid into the DB.
Yes.
Okay, that's fine. Yeah, that's perfectly fine.
I think that we don't have that part, frankly speaking, but I think, you know, I think all the SONiC's current work is under something that, you know, the configuration that has been input into the config DB is valid, so he can do the job. And yeah, so that's where he has those assumptions in the first section. And I think it's in the later we'll try to address it to add a front end checker and to check all the input into the config DB so that we can make sure that those input has been valid.
That's fine. As long as it's just, I'm not looking for implementation, but it would be good to point out in the document that we expect in the future that we've already defined the place where the validation is going to happen. That's all.
Hey guys, I would like to add something here. It's true that we should push that logic of validation to the front end, but we have to make sure that orchestration agent is protecting the rest of the box in the system, so that a user, you know, with an IP or config CLI on the Linux shell cannot crash the entire system, right? As we have seen in the past. So that logic has to also be there in orchestration agent. So I don't think it's one or the other. We have to take care of these cases in both places.
So you're saying if the user is circumvent our SONiC command line and use Linux shell-based command line, that will have another defense line?
Yes, that's what I mean.
No, I think it's more along the lines of saying, for example, you try to download multiple link local addresses over multiple interfaces, but the link local address is the same, right? And currently, I think if we address that inside, then the users should be okay with the check that Sotian and Gohan plan to have at the front end, and org agents shouldn't need to worry about those cases. At least that's what I think. Gohan?
Yeah. So I feel that if the user wants to use IP configuration to config that, I think that is error prone, because when we do those configuration, we have to make sure you know, different components are valid. It's not like you know, in this model we're not provide support for IP utility, Linux IP utility commands. I think in our model, if the true source of truth lives in the config DB, I think it's a little bit challenging for us to support the IP model.
So in terms of overlapping IP, exclusively in terms of that, as you know, we already at LinkedIn, we're already using that code, and that is the way that we are implementing link local, right? So I do agree that ideally it should be on the front end in config, you know, just to make sure that everything that goes in config DB is valid. But in the absence of that, having this in orchestration agent can only help. It cannot, you know, is not an issue that can hurt you and would only help you. That's all.
Yeah, I think in terms of a defense line, you know, adding some extra defense line in the, you know, a lower level of the components can, you know, maybe help the system crash or those kind of benefits. But I think still the main defense line would be, you know, prevent them from getting to the config DB.
Yeah, okay.
Yeah, okay. So so I don't have more time. And right now, this is a starting working device start flow. So the first part is to create all the ports, and then we're going to define all the IPs. Then we're going to create all the port channel and members. So the tricky part is the Docker SWSS restart and teamd restart. Later, I will going to add the full workflow here. So I'm going to add some test cases in the virtual switch test and integration Ansible test. For the virtual switch test, I've already added some of the IP tests. I'm also going to add some port channel manipulation tests there to make sure that all the functionality will working fine. Yeah. So I think we only have 5 minutes left. So anyone has some questions? Xin, do you want to take it back? I think I'm done with the presentation.
Okay, thanks, Sortian. Just want to know that if anyone else have comments, thoughts to share. So this design doc has been published. Can you show, Sortian? The pull request is under SONiC. Again, all the design doc are under pull request, and feel free to add your comments, and we need to close them. Yeah. Okay, so for the next few community meeting, we have a few topics that line up will be discussed. One is a basic VXLAN and WRF design. The second one is management WRF. We talk about the design doc. We haven't covered the test plan yet. That will be one session too. And another session will cover a watermark. For like this is for a feature for RDMA troubleshooting, design and test plan. These are the things in the immediate queue to be discussed. Any questions or comments from the audience? Okay, no. Thanks, Sortian, for leading the discussing, and thanks for everyone for your time. Yeah, and then see you next week. Yeah, bye.